Okay, so my lesson is over symmetry. My topic is, of course, symmetry. The age group is 3rd grade, and I have a class of 20 students. Here we go. Good morning, class. Today we'll be learning about symmetry. Can anyone raise their hand and let us know what symmetry means?
Yes, symmetry is when you can divide something.
You are absolutely correct. Symmetry means to divide something into equal parts. Does everyone remember our lesson yesterday when we learned about halves?
Yes!
Fantastic! We learned about how to cut different shapes into equal parts. Well, today, you guys are going to be learning about how to find symmetry in all sorts of shapes. Let's get started. So, class, let's give a formal definition of symmetry. We already said it means to divide a shape in half. When we divide a shape with a line, such as a circle, is it okay if one side is bigger than the other?
No!
You're right. The sections must be equal and look exactly the same on both sides. I'll write our definition on the board, so please open your math journals and write up this along with me. Symmetry. When a shape can be divided into two equal parts, where each part is an exact reflection of the other. What word stands out in that definition to us?
Reflection.
Yes, reflection. We've all seen reflections before when we look in the mirror, and we can see what we look like. Well, shapes have reflections too. Let's take a closer look at how reflections affect symmetry. In your journals, write along with me our first symmetry example. Example 1 is, find the symmetry in this figure. How many ways can we find symmetry? And this is a regular square. All the sides are equal.
You can draw a line from the top to bottom in the middle.
Yes, that's one way you can draw a line of symmetry in this figure. Draw a line from the top to the bottom from the very middle. We call this a line of symmetry. Notice that each is a reflection of the other, each side that we see. What other lines of symmetry can we make with this square?
From left to right?
Yes, we can draw a line of symmetry from left to right across the middle of the figure. Again, notice that the top is a direct reflection of the bottom. We can say the two sides are symmetrical. There are two more ways to find symmetry. Can you tell me what those are?
You can draw lines from the corners diagonally.
Great job! You can draw two more lines from the corners going across each other in an X shape to create symmetry here. Great job, class. Let's try another example. Our second example is a star. So how many ways can we find symmetry in this figure?
Can you draw a line from top to bottom?
Yes, we can draw a line of symmetry from top to bottom. Notice that the left side is a direct reflection of the right side, and the two sides are actually equal. Are there any more ways to find symmetry in this figure?
Can you draw a line from left to right?
We might be able to draw a line from left to right. Let's try it. So when we've split a star up in half, top and bottom are separated, is the top still a reflection of the bottom?
No, they aren't equal.
Good job. In this case, the top is actually not a reflection of the bottom, and the two sides are not equal. So there is only one vertical line of symmetry in this case. Let's try one more example. Our third example is an arrow. It's an arrow pointing upwards, and can we find any lines of symmetry here?
From top to bottom down the middle.
Exactly. The line of symmetry is drawn from top to bottom, right down the middle. Each side is a reflection of the other. Can we draw any more lines of symmetry?
No, there are no more lines of symmetry you can draw here.
Yes, that's correct. There are no more lines of symmetry that we can draw here. Nice work, class. You all did a great job with our lesson today. Now let's do a fun activity. I'll be passing out to each of you a sheet of paper with various shapes on them, as well as a piece of construction paper. You will cut out each of the shapes from the paper and find the lines of symmetry for each of them. Some shapes will have lines of symmetry, while others will not. On your construction paper, you will draw a line down the middle, separating the paper into two categories, which you will label symmetrical and not symmetrical. You will then glue the shapes onto the construction paper accordingly and place each one in its appropriate category. I'll be walking around the room if you have any questions along the way. Let's get started.
Miss Johnson, did I draw the right line of symmetry on this figure?
Let's see. You drew a line straight across this figure. Remember that for each side to be symmetrical, what do the images have to be?
Reflections?
Yes, the images have to be reflections of the other. Are these two sides reflections of each other?
No, they aren't.
Good job. These actually are not reflections of the other. Can you find any more lines of symmetry in this figure?
No, I can't.
Great. There are actually no more lines of symmetry in this figure. So where should we place this picture on our construction paper?
On the not symmetrical side.
You're right, on the not symmetrical side. Great job.
Miss Johnson, did I draw a line of symmetry on this picture?
Yes, you did. If you look here, each side is exactly the same as the other side. They are equal to each other.
Okay, great. I was just a little unsure.
I'm glad you asked. You're doing a great job so far. Keep it up. So you all did a wonderful job with our lesson and activity today. Let's review what we learned. What does it mean for an object to have symmetry?
It means that when you draw a line, the two sides are equal to each other and they reflect each other.
Fantastic! You are correct. If we draw a line through a figure, we create symmetry when the two sides are equal to each other and they reflect each other. Can anyone tell me when a figure is not symmetrical?
It won't be symmetrical if the sides split up by the line are not equal to each other.
You're right. A figure will not have symmetry if you cannot draw any lines through it that can create equal sides. What was one figure from your activity that had symmetry?
The butterfly did.
Yes, the butterfly had a line of symmetry right through the middle, going from top to bottom. This should have gone in which category?
The symmetrical one.
Great job. Can anyone think of a shape from our activity that didn't have symmetry?
The triangle did not.
Correct. In this case, we had a right triangle, and none of the sides were equal. The triangle from our activity did not have any lines of symmetry. So from our activity, we can see the butterfly shape had symmetry. Other shapes from nature, like leaves and trees, have symmetry. So this is kind of something you can take out with you to the real world. And I challenge you to go home tonight and think of an object from your house or from nature that has symmetry and share it with us tomorrow, or bring it to class if you can. We will be learning about different transformations of shapes tomorrow, and we will use our knowledge from today to help us. Great job today, class!
Thanks, Miss Johnson!